Hello friends, welcome to Padhakooo, your free way to success. Click on subscribe button and do not miss another update from Padhakooo. Friends, if we have entered an electrical engineering program, then circuit analysis represents large fraction of our total study of electrical engineering. Circuit analysis is prerequisite to machines, power systems, measurements, and a large portion of electronics. Starting with network theorems. When we have complex networks having nodes and meshes in very large number. If the number of nodes and meshes in a particular circuit increases, then it is very tedious task to solve the circuits, to calculate the responses. So network theorems come into existence. As they are used to solve circuit responses easily. Now, talking about network theorems, these are Superposition Theorem, Thevenin Theorem, Norton Theorem, Maximum Power Transfer Theorem, Millman's Theorem, and Telegrand's Theorem. Today we will be discussing Superposition Theorem, and rest all the theorems will be discussed in upcoming lectures. So stay tuned to my YouTube channel Padhakooo. Now coming to superposition theorem. In any linear bidirectional circuit having more than one independent source, the response in any one of the branches is equal to the algebraic sum of the responses caused by the individual sources. Let us take an illustration. We have source 1 and 2 with resistances R in same circuit. It is a simple circuit. As we can see, it's a very simple circuit. According to definition of superposition theorem, activate one source and deactivate all the other to find out the individual response. So here S1 is activated and S2 is deactivated to find out the response I1, and subsequently S1 is deactivated and S2 is activated to find the response I2. As you can see, S1 is activated in first and deactivated in second case, and S2 is deactivated in first case and activated in second case to find out the value of I2. So the total response is, let us say I, as total response is I, which is equal to I1 plus I2, and which is sum of the individual responses. I1 plus I2, which is sum of individual responses. So here we get to realize that the response due to S1 is I1 and response due to S2 is I2. Now moving forward to the second half of the definition, that is, while the rest of the sources are replaced by its internal resistance. What does this mean? So talking about a practical current source. A practical current source consists of a shunt resistance across the source. It consists of shunt resistances across the source. Generally, this value of RSH is very large, that is approximately infinite. The value is very large and approximately infinite. And a practical voltage source, talking about a practical voltage source, it consists of an internal resistance in series with the voltage source. So we will be making a practical voltage source here. So this voltage source is a voltage source which is in series with the its resistance is in series with the voltage source. The value of internal resistance is very small and approximately is equal to 0. Let us say RINT, which is very less and is equal to 0. Now to complete circuit, let us talk about the current source. To complete the circuit, current has to pass through the current source. Therefore, due to the current divider rule, all the current is to be passed through the current source, and the negligible current passes through the RSH, which in turn is responsible for its infinitely large value. And in the case with voltage source, all the current has to be passed through the voltage source, and therefore it has to pass through the resistance, and value of R internal must be very small or negligible. So, as the superposition principle states that the current source can be replaced by an open circuit and the voltage source can be replaced by an short circuit. By an open circuit, current source can be replaced by an open circuit and the internal resistance of a voltage source can be replaced by, as it is stated as at 0, so it can be replaced by an short circuit. Now, let us solve one question regarding superposition theorem using superposition theorem. Okay, so this is the value of I we have to find out in the question. So let us start. Here we are having two voltage source, sources. One is voltage source, another is current source, and we have to activate one and deactivate the another to find out the response I. So in case when we activated V1 and we deactivated the current source, and so as the current source deactivated, then the current source is replaced by an open circuit, which is shown here. How the current is deactivated and it is eliminated from this particular circuit, and in place of that open circuit is placed. So we have to redraw this circuit by eliminating the current source. So 6 volt battery is here, V1 source is here, and then 8 ohm resistance will be, we'll see 8 ohm resistance and 6 ohm resistance in parallel to this. And we can complete the circuit by looking at the circuit diagram. So here I am completing the circuit. This is again 8 ohm and 6 ohm again, and we'll be joining these two 6 ohm resistances. Yes, we have to write ohm also, and we connect these two, and here the current source which is deactivated is replaced by an open circuit. Now to solve this kind of circuit, it's very easy now to solve this circuit and find out the value of I in the 6 ohm resistance. So here we can see that if we have to redraw this circuit again, so 6 volt is there, and 8 ohm and 8 ohm are in series, and 6 ohm and another 6 ohm are also in series. Now these two resistances are in parallel to the voltage source, so 6 ohm and 6 ohm resistance will share same potential, that is plus minus. We'll be denoting the value of plus and minus by changing the colors. Blue 6 volt. Now to find out the current in this branch, we can say that it is equals to V over R, and here V is 6 volt and R is 12. So we can say that 0.5 ampere current is flowing, as we can see that the direction, the polarity is as shown, so current will be flowing from top to bottom, or we can say the sign of the current is positive. We can say that 0.5 is in plus. We have written the sign of the 0.5 ampere is plus, so the current is flowing in downward direction. If current is flowing downward direction, we have made our convention so that the current which is flowing in downward direction is having sign plus. Okay, now talking about case 2. In case 2, we have to activate the current source and we have to deactivate the voltage source. We have to activate the current source and we have to deactivate the voltage source. So we can say that V1 is deactivated and I1 source is activated. Yes, activated. Now talking about this kind of circuitry, we have to redraw this circuit again by replacing the voltage source with a short circuit. Here, like, just we have to replace this circuit by short circuit, like this, like this. Now we have to redraw this particular circuit again. We are having 2 ampere current source, and to the right of this circuit we'll be drawing 8 ohm resistance and 6 ohm resistance there, and to the left of this circuit we'll be drawing again 8 ohm and 6 ohm. As we can see that to the left and to the right, both are the resistances are same. So by applying the current divider rule, we can say that 2 ampere is getting divided equally as 1 ampere in both the branches. So we are taking into consideration only the right branch, and we can say that the current is flowing which is having value of 1 ampere and flowing upward in this circuit, in this branch which we need to determine. So our convention is from top to bottom, and so therefore the value of this current is negative. Now according to superposition theorem, we have to add these two individual responses to get the total response. The response which we obtain from case 1, and the response which we obtain from case 2. So I equals to I1 plus I2, and I1 here is 0.5 with the sign of plus, and I2 is 1 ampere with the sign of minus. So we can say that we are having a current of minus 0.5 ampere. So it's opposite to the direction which we have assumed. So the current is flowing with a magnitude of 0.5 in upward direction. The value is 0.5 ampere, and in direction is upward. Okay, now solving another question, the value of VAB using superposition theorem. Here the value of VAB is to be calculated. Now dependent sources is present, so we have to we do not have to touch dependent sources in any condition. The dependent sources are left untouched. So here also two sources are present. One is voltage source, another is current source. We have to deactivate one and activate another, and find out the responses and add as we have done in previous question. So to find out VAB total, we have to find out the individual responses Now how to find out the individual responses? Individual responses can be calculated as VAB, which is VAB1, which is due to source 1, and VAB2, which is due to source 2. When source 1 is activated, we have to obtain value of VAB1, and when source 2 is activated, we have to obtain the value of VAB2. So case 1 states that voltage source is activated and current source is deactivated. Here voltage source is activated and current source is deactivated. And current source is deactivated. Yes. So by applying KVL, we can say that yes, we have to deactivate this, and this current source gets eliminated from the circuit, and it is replaced by its internal resistance. That is, we can replace it by an open circuit. So we are left with an open circuit. Yes. So by applying KVL from let me write it, by applying KVL starting from this point and applying KVL in this direction. As we can see, we'll be writing plus 10 volts, and it passes through the resistance, but it does not affect because we cannot see any voltage drop as there is no current flowing in this particular branch. So coming on to dependent sources, we can write minus 2 VAB, and across this open circuit element we are having voltage VAB, and we can write it as minus VAB, yes, which is equals to 0. Now 10 volts equal to 3 VAB. This implies that VAB equals to 10 by 3. So here we have obtained VAB1, which is due to source 1. Another thing, now we have to find out another individual response with the help of case 2. And in case 2, the current source is activated and the voltage source is deactivated. And current source is activated and voltage source is deactivated. Voltage source is deactivated. Okay. Now here let me mention this, 2 ampere current is activated and 10 volts is deactivated, so I'll be replacing it with a short circuit line. Now as this circuit is completed, so 2 ampere current will flow, and in this time resistance will observe a voltage drop, as we can say current I equals to 2 ampere will be flowing in this direction. By applying KVL in the closed loop, applying KVL in the closed loop we can say starting from here, moving on across the current source, we can say that we will be having voltage VAB, which is across this particular current source. So by applying KVL, we can write plus VAB here, then plus 2 VAB, which is of dependent source, plus 2 VAB. Now here we are observing a voltage drop, so we can write as minus 8, or we can say that I into R, minus I is equals to 2 and R equals to 4. We can write it as 4 into 2. We are observing a voltage drop here, and this line is short circuited, so no problem, is equals to 0. Then we can say that 3 VAB equals to 8. This implies that VAB equals to 8 by 3. So this is another response which we obtained by case 2, which is another response. So according to superposition theorem, the total response will be getting the total VAB is equal to VAB1 plus VAB2, which is from both the sources. According to superposition theorem, VAB equals to VAB1 plus VAB2, which is equal to 10 by 3 plus 8 by 3, which is equal to 18 over 3 and can be stated as 6. So VAB total is equal to 6 volt.